So here's the periodic table, and the shape of the periodic table actually corresponds perfectly with the number of electrons that can be in each sublevel according to quantum mechanics. And what blows my mind is that Mendeleev put the elements in this arrangement before he even knew what electrons were, right? And then we discover quantum mechanics later, and it matches up perfectly. It's just mind-boggling. So here we have a periodic table where the different sections are colored, they're color-coded for the different sublevels that are being occupied. So the blue over here, we call these the S-block elements. These are filling up an S room, an S orbital that can hold 2 electrons. There are 2 columns here. The pink is P block. A P sublevel has 3 orbitals and can hold 6 electrons. How many columns are here? 6. The yellow is the D block. The D sublevel has 5 orbitals. It can hold 10 electrons. Count them, there's 10 columns. And these guys down here, which actually we should cut the periodic table apart and stick it in there, which is how it is up here. This is the F block, 7 orbitals, 14 electrons. There are 14 columns. So we can actually read electron configurations directly off of the periodic table. The period number corresponds to the principal quantum number, principal energy level. So hydrogen has 1 electron. It's in the 1s orbital. Now, yeah, helium's over here. He's also one of the baby brothers, and so he, violates a lot of rules. For these purposes, he should be over here, but we don't put him over there because he's really a noble gas. But we just let him be out of place. So that's 1s, and there's the 2 electrons. And here's lithium. Its last electron goes into the 2s orbital. And then beryllium will fill up that 2s orbital. And then when we go over to bromine, now we're adding an electron in the 2p. 2p, 1, 2, 3, 4, 5, 6. That fills up the 2p sublevel. We come over here, and now we're to 3s. 3s, 1, and 2. And we skip across here. We're at 3p, 1, 2, 3, 4, 5, 6. And over here is 4s, 1 and 2. Now this is where that messed up ordering comes in. So I think of this D block as having sunk, right? Kind of like the valley floor is sinking. Did you know that? So it kind of looks to me like it should have been up there. That this is part of period 3, the 3rd row, but it's sunk. This D block is 3D, not 4D. So for the D block elements, you're going to have n minus 1. Whatever the period number is, and the period number corresponds to the principal quantum number. So for these guys, it's n minus 1. So this is in row 4. This is actually 3D. You go through 1 through 10. Now over here, this part isn't sunken, and so this is 4p, 1 through 6. We come over here, here's 5, 5s, and then we get to the sunken part again. So that's 4d. We go through 4d, now we're back to 5p. We come over here, 6s. This would be 5d, and then we go down here. The F block I think of as being even more sunken, and this is n minus 2. So this group, yeah, question?
Yeah, back to like my question.
Mm-hmm.
If each level of the room is more expensive, so
Mm-hmm.
they want to stay on the lower rooms,
Right.
the cheaper rooms. How can a level 6 be before level 5? Like
So in the hotel, right, in general, the lower the floor, the less expensive the room. But on the 4th floor, the S room is cheaper than the 3D room. We can make up a reason in the Quantum Hotel because it is a figment of my imagination. So I imagine that maybe that room has a faulty air conditioner, or maybe it's close to the ice machine and so it's really noisy and people would rather not stay there, but they'll stay there if it's cheaper. That D room is further from the elevator, it's really nice and quiet. Make up a reason. Okay? What this is doing, this helps us to know what that wacky order is. Like I mentioned, the actual explanation is that the 4s orbital it has a lobe of it that is much closer to the nucleus than the 3D orbitals. And so it can penetrate in, and so it experiences a stronger attraction to the nucleus, which lowers its energy compared to the 3D. Okay? So we have the actual scientific explanation, and then we have a practical, how do we do what we need to do? How do we remember this stuff? Does that help? So the F's, so we come across here, and we're not going to get too hung up on why there's one yellow one here, and then we go into the green. But these are the F blocks, and so 1 through 14, this is coming from period 6. The F blocks are n-2, so this is 4F. So this is the 4F room filling, and then we go back and finish filling up the 5D, and then we have 6P, 7S. One guy goes into the 6D, and then we go into the 5F. We come back and finish up with the 6Ds. And so all of that ordering is actually in the periodic table. There's another way you can remember it where you write out this list of things, then you start drawing diagonal lines. I think that's in your textbook. If that works for you, go right ahead, or if you just want to flat out memorize it. But I prefer to see the periodic table as my roadmap for writing electron configurations.